Okay, so this is going to be a very advanced video on rotating parabolas. And so I've got my basic parabola y equals x squared, and then I can flip it upside down, and I can turn it on its side, and I can make it go to the left. And so those are boring. Those are just like rotations by 90 degrees. And that's just not really all that exciting. I don't want to rotate by 90 degrees. I want to rotate by something different from 90 degrees, or 180 or 270 or 360. So what we have to do is we have to look at rotation matrices. And so here, the Wikipedia has this thing on these rotation matrices, and it took me a long time to figure out that I actually don't want this rotation matrix. I want the transpose of this rotation matrix. That's what's going to do the trick. So down here, it's got x prime and y prime. It's got x prime is x cosine theta minus y sine theta, and y prime is x sine theta plus y cosine theta. But I really want x and y in terms of x prime and cosine, x prime and y prime. And to do that, I need the transpose of this. And so to save a little bit of time, I kind of did it up here. So this is going to be the transpose. X is going to be x prime cosine theta and y prime sine theta, and y is going to be negative x prime sine theta plus y prime cosine theta. Okay, so this is complicated. I understand that. And I just hope that if you just sort of hang with it, you're not going to understand it now, but then you're going to understand it later when you do some other math classes. So this is right here. This is the transpose of the rotation matrix. Okay. So what that tells me is I want to take, if I want to rotate things, you have to excuse the software for 1 second. There's my keypad back. If I want to rotate things by theta equals 1 radian, okay? So there I've got a line that's theta equals 1 radian. Well, what I'm going to do is I'm going to say my y, I'm going to replace with negative x sine 1, negative x sine 1, plus y cosine 1, is equal to my x, which is x cosine 1, plus y sine 1. And then I got to square that. Okay, so what is done is it has rotated everything. This rotates everything 1 radian counterclockwise. So it took my x-axis and made it this line here. It took my old sort of directrix and rotated it up, took my old axis of symmetry and rotated it to the left, and so I took everything and rotated it to the left. Okay, now suppose I want to do this. I want to do y minus 3 equals x plus 2 squared. Well, now let's make that. Let's put that down there. Well, now if I want to rotate that, what I have to do is just copy this And wherever I see x, I want to replace it with x plus 2. Let's put that in parentheses. And there I've got an x that I want to replace with x plus 2. And then let's put that in parentheses. Copy all that. Take all my y's, replace them with y minus 1's. And if I hit it, there I've taken my green one and I've rotated it to get my light blue. So there's my green, which is now red, and make it a darker blue. So take out some of this stuff here. And so there, my blue is the parabola centered at -2 comma +1 that's been rotated by 1 radian to the in the counterclockwise direction. So where is this going? Well, what I want to get to is this idea that okay, definition of parabola is the set of all points equidistant from a fixed point and a fixed line. Well, instead of doing boring lines, I want to do a fun line. Let's not get too crazy, but let's do y equals 2x plus 3. So there's a line. And then let's come up with a point. So my point that I want to come up with is let's call -1, -1, -2. So there's my point. So I've got a line and I've got a point. Well, I should be able to come up with a parabola, and that parabola should kind of open down and to the left. But how do I find the equation for the parabola? And I'm going to leave it in a messy state when I'm done, but we are going to find an equation for the parabola. Okay, so first thing is to find the axis of symmetry. Okay, well, that has a slope perpendicular to the directrix and passes through the focus. Okay, so my slope up here is -2. So I have passes through the directrix. I always like point slope. So I've got y plus 2 equals, well, that's going to be 1/2 x plus 1. Okay. So the slope of my directrix is -2, and then the slope of my perpendicular is going to be 1/2, and then it's got to pass through the focus, which is -1, -2. So it goes through. So there's my equation right there. Okay, so now I just want to put that into y equals mx plus b. So I want to get y equals 1/2 x, and then I've got 1/2, that's going to be -3/2. Okay, so I just wanted to put that into y equals mx plus b. And now we'll just get rid of this. Okay, so now I've got a directrix, I've got a focus, and I've got an axis of symmetry. Okay. Next, find where the axis of symmetry intersects the directrix. Okay, well, what I want to do is I want to set them equal to each other. So I've got that. So I want to go that is equal to that. And then I want to change it around, so I'm going to have 5/2 x is equal to 3/2. That's 6/2 plus 3/2 is 9/2. And so then I'm going to have x is equal to 9/5. And then I do up here, y is equal to 9/5 or 1/2 times 9/5 minus 3/2. And that's going to be at what? If I just take this away, negative 0.6. So let's just, yep, so negative 0.6. So now I've got a point that is, let's graph another point. We are at the point 9/5 and negative 12/5. Let's see, negative 0.6 is negative 6/10. It's negative 3/5. Sorry. There we go. And so now I have found the place where the axis of symmetry meets up with the directrix. And I want to pull out, again, we're going to be full up with all kinds of stuff. So I want to delete when possible. Okay. Now, the next thing, now find the vertex halfway between the focus and the directrix. Okay, well, so that's midpoint formula. So I go over and I open up a spreadsheet. And so my focus is going to be, what, -1, -2. My other point that I just found, directrix, let's call that equals 9/5, and call that equals -3/5. And so the midpoint, the vertex, is going to be equal to that plus that divided by 2, and just copy that over. Okay, so now my vertex is going to be, what was it again? 0.4, 0.4, and -1.3. Okay, so now we're getting someplace. We found our vertex. Okay, now let's find P, the distance from the vertex to the focus. Okay, back to our spreadsheet. So there's our vertex, there's our focus. So P, well, this is going to be Pythagorean theorem. This is our distance formula. So this was midpoint formula. And then this one is going to be distance formula. So we're going to say that's equal to focus minus vertex squared plus focus minus vertex squared, all to the 0.5. Did I do that wrong? I didn't do that correctly. Because it's got to be B3 and that's got to be C1. That's got to be C3. I clicked wrong. There we go. So my P is equal to 1.56525. 6525. Okay. So now we're going to come up with a parabola that we're going to say 4 times P, which is 1.56525, y is equal to x squared. Okay. Now that's a parabola that opens up the correct amount for that P, but I still haven't made it on the vertex yet. Well, to make it on the vertex, I take my y and I replace it with y plus 1.3, and I take my x and I replace it with x minus 0.4, and now I've got it opening up the correct amount and it's on the vertex, but it's not rotated. So the question is, how far has my directrix been rotated? Well, that directrix has been rotated pretty severely. Before it was here, but then it goes all the way over to here, so now it's got a slope of -2. Well, to figure out how far it's been rotated, I go all the way back and I take that and I find the arctangent of the slope. So a tan of -2 is -1.107.15. So then going back and show my keypad, theta equals -1.10715, and let's make my r is equal to 100. And let's make that darker. And I got a problem, because that's actually not how I rotated it. I didn't want to rotate it this way. I was expecting to be up here. I wanted this to be up here. So what I have to do is I have to add pi to that. That's the rotation that I want right there. So if we look at my previous one, where did I have it? to go from here, to rotate it to the left, I went up that far, but now I want to kick it over to that way. So if I just do the arctangent of -2, it gets me this -1. But what I really want is plus pi. So I want 2.03444. Okay. Okay, so now let's come up with a rotated parabola where I'm going to say that I've got, instead of y, instead of y, I've got -x sine of theta. So I've got -x, I don't want it gray, -x times the sine of 2.03444. Let me go back and look at that again. Plus y cosine theta plus y cosine of 2.03444 is equal to, then I've got x is going to be x cosine theta, so x cosine 2.03444 plus y sine 2.03444. And then I got to remember to square that. Okay, so now I've got my parabola pointed in the right direction, but it's not opening up as well as it should. So I got to take this and I got to multiply this by 4 times my p, which is 1.56525. Now it's opening up the correct amount, but it's not going through my vertex. Well, what I have to do to make it go through my vertex is, once again, I got to take all my y's and I got to replace them with y plus 1.3's. And I got to take my x's and replace them with x minus 0.04. And I graph that. And if I take away all the garbage, take that away, take that away, and what I have found is I have found the parabola that is equidistant between the line -2x plus 3, y equals -2x plus 3, and the point -1, -2. That is the correct, and so the equation for that parabola is going to be this awful mess here. And could I clean it up? Yes, I could clean it up. Am I going to clean it up? No, I'm not going to clean it up.